There's a couple ways you can play this. Let's see, solve. Which one of these do I want to do? I don't want to do that one. Okay, how about this one? Well, what kinds of equations are these? Do you recognize any of them? What's the squares? Yeah, this one's quadratic-ish. The bottom one is. If I solve for y, I would get negative x squared plus 5. And what would the graph of this one look like if it's quadratic? It'd be a parabola. And better yet, it's a parabola that opens down because of the negative x squared. And all that. So it's going to look like that, right? So one of those equations is a parabola. But what about the other one? I'm thinking of a word that starts with a C and it rhymes with circle.
Circle is the x minus h.
How do I know this is the equation for a circle? It's x squared plus y squared, right? And this would equal the radius squared, right? So this is a circle. Where's the center? We didn't translate this guy at all, did we? We didn't move him up, down, left, or right. And because there's nothing inside parentheses for the x squared, so the center's just at 0, 0. And what's the radius? 5. So it looks like that. So I'm looking for where does that circle intersect with that parabola?
The center is 0, 0 because there's no... Okay.
Yeah, there's no number in here, like versus if I had x minus 2 squared plus y plus 4 squared equals, let's say, 1. Yeah, then the center's at positive 2, negative 4, and the radius is 1. But if I'm not adding or subtracting anything from the x or the y, then yeah, it's going to be understood at 0. Alright, so graphically, if we're a little careful with this, then maybe stuff works out. Oh, no, I'll just do it by hand.
Are you saying solve? Are you solving or graphing?
Oh, well, I'm solving by graphing. If I graph these guys and I find where they intersect, those points of intersection are the solution for the system. I'm looking for where do these equations have the same x and the same y at the same time.
Okay.
So for a circle centered here, 1, 2, 3, 4, 5. 1, 2, 3, 5. Okay, true or false? Be honest. Is that a perfect circle?
No.
See, that's brutal honesty right there. But it's not, correct? And this is going to be a relevant point here in a bit. Okay, not a perfect circle, but it's a good representation. I mean, it's circular-ish, right? It looks more like a circle than other things, right? Okay, so the next step, we have a parabola that opens down, but do we know how to graph that parabola? Yeah, we've just moved it up 5, haven't we? That's what that plus 5 means, and it's outside the squaring, it's all that stuff. You see what we're doing here? We're reviewing all of these things from earlier, right? It's the perfect review topic. Okay, so I bump it up 5, but it opens down, so it has like some points here, here, let's see, 1, 2, 3, there,
Are you getting the 1, 2, 3?
hold it up. Maybe? You get the idea, right? It's not a perfect graph, right? But it does give you the idea. How many solutions do you think we're going to have? I think definitely these two, but this one as well. I know for a fact that they both go through this point, so that would be another point where they intersect. So I'm thinking 3 solutions, okay? And this one, let's go ahead and all agree that 0, 5 is one of those solutions. They both go through 0, 5, right? But what about these other two? Did anyone do a very exact circle and a very exact parabola on nice exact graph paper? Did anyone do that? So how do we get those points? We redo it, but this time more exact? No, we have other options. All right? We had those two non-graphing methods for solving substitution and elimination, right? Sometimes you can do substitution with nonlinears, sometimes you can do elimination with nonlinears, and this is going to be a case where I think we can do elimination. I think if we tweak our equations just a little bit, I'll be able to add those two equations together and get one of those variables to drop out. Because in both equations, I still have x's and y's, right? I could also possibly do substitution, but I think that would be a nightmare. I could solve for this y easily, and I already did, right? And if I'm doing substitution, then I'm taking whatever y equals this, and I'm plugging that in for y there. But can you imagine that? I'm squaring this. And that just feels like it's going to go badly, right? So here's how we can maybe attack this problem doing elimination. I want to add those two equations, but I want one of them to drop out. Well, notice my x squareds. These are x squareds and these are x squareds, right? So if I make one of these a negative by changing all my signs, then adding them together, x squared minus x squared gets all the x's to drop out, doesn't it? So I could take my first equation as it is and do the negative of my bottom equation. And now when I add them together, x squareds cancel, and I get a y squared minus a y equals a 20. And I can do something with that, right? In terms of y, that's not a quadratic equation, and I could either do like factoring or completing the square. I'm not going to do completing the square. But I could do factoring, or I could do the quadratic formula, or something like that, right? Is there any way that y'all want to do it? Say factoring. Let's do factoring? Good idea. So I'm going to subtract the 20 over to get this in standard form. So I have y plus minus, yeah, plus 4 minus 5, right? And from there I get two solutions. I get y equals negative 4, or y equals positive 5. Now one of those I was expecting. We already decided that 0, 5 was going to be one of the solutions, right? And that has the y value of 5. So how do I make sure to get that x value of 0? Well, I take the 5 and I plug it in for y in one of these two equations. Do y'all care which one? Then let's do the bottom one. If I plug in 5 for y, then x squared plus 5 equals 5. Subtract off the 5. And if x squared equals 0, what is x going to have to be? 0. So that means one of my points is 0, 5. And that was the one I was expecting, right? That's for the y equals 5 case. But what about y equals negative 4? Does that look like maybe what's going on down here? Could these 2 points here have y equals negative 4? And when I plug in